All right, hey friends. So today we're talking a little bit about how to do some console linking with an XM32 environment. They're built on OSC, so it's actually pretty straightforward to do. What we need is to be able to receive information from an XM32 console and then forward that in Osculator to another console. It really is just that straightforward. We're taking a value from one place, which in this case, we're going to call it channel 1 mix/fader 01, and we are going to send that on to another destination. But before we talk about that, we need to talk about how we get data from the X32 console to be seen in Osculator. And in order to do that, you need to subscribe. So you may have seen right here, every 8 seconds, right down here, there we go, bam, we have this X remote command that is going and going and going and going and going. Now that's actually really important. In order to subscribe to data from the console, you have to send that command out every 8 seconds or less. I have a delay in here that's set to about 7,800 milliseconds, so about 7.8 seconds. That's going to be going out. So how do we do that? Well, first you need a catalyst to start a loop, and then the loop will sort of live until you stop it. So how do we start it? Well, if you come up here to your mapping button here, if you come down here, you'll see this trigger a message when mappings are restored. So what you can do is you just create a mapping 2. Doesn't actually have to have anything in it, just a mapping 2, and then you have a mapping 1. And you'll notice that as the instant that I came back to default mapping, Osculator / mapping sent out a trigger that is a MIDI note, a C-2 on channel 16. And that started this stuff going down here. This is our first step. So we are sending out of Osculator a C-2 on channel 16. And in order for that to do what we want, we also have to have an IAC bus that it's listening to. In this case, I'm using an IAC bus called Osculator Loop that is both an output in Osculator and enabled as an input in Osculator. So anything that's coming out of Osculator on this loop MIDI is going to be seen on the input of the loop MIDI. Now, that does possibly present some problems if you've got a ton of MIDI stuff that is coming to and from that you don't necessarily want to listen to. So you got to be kind of careful about that. In this case, I'm using channel 16. I tend to use channel 16 only for a certain program data, I guess, is the word that I'm looking for. So just certain sort of console and utility things, and then I work backward from there for other sort of things that I might want to use my MIDI for. So, all right. So what's happening then is as soon as I set this default mapping, it sends this C-2. So let's go look at our note and what that actually does. Note. So when a C-2 is received on channel 16, we send out a X remote trigger to destination 4. In this case, that's going to be my console. I don't see. Let's just show you where my destinations are on our OSC route. So there it is, console IP address. I got to make sure your port is 10023, and you can see I've labeled that X32 core and X32 rack. Now, you can also add a bunch of rewrite addresses, and you can see I've done this in here, and that's what we're going to use for our forward to the other console. But we're not going to get there quite yet. We're going to talk a little bit more about this MIDI trigger. Okay, so when that MIDI note is received, I send out an X remote command. Then it has a delay of 7,500 milliseconds, and then it sends out another C-2, which then causes this thing to send out an X remote, and then another delay, and then after the delay, the C-2. So this is going to happen ad infinitum until you stop it. Now that that is going, now we are subscribed to data from the X32 console, and you can kind of see these float values changing there in this little window right here as I move in that fader. Once I have that information, so now we're looking for /channel /01. And then what do we say? I think it's fader. Mix/fader. Mix. Okay. So once we have that, so you can see I've got my channel 1 /mix/fader. That's my input message. Over here on my event type, I can change this to OSC, and then I can change this value now. I've got channel 01 mix/fader. Now that's where this table comes in handy. So you're going to need to do a little bit of legwork here, and you're going to need to come in here and you're going to need to create some messages that are corresponding to your desired destination. And you can see I populated my desired destination, my core, number 3. And we can say channel 1, mix fader, whatever. And the end result now is that when I move this fader, you can see that I've got a green light and an OSC message that is now being forwarded to this new destination. That is the same thing as the input, and the desired result is on my x32, my other console. As soon as I move this fader, the other fader responds. See if I can get wide enough to show you both at the same time. There it is. Voila. Now, the other important note is this is a one-way direction, or this is a one-way communication right now. So if I come over here, oh, right, I'm on the... So if I come over here, and I'd move this, I'm just going to do this with my finger. If I move this, you're going to notice the other console does not move. So you can do that. You can get the sort of the reciprocating messages sent back from here to here, but that is a much more complex endeavor, and you can end up with infinite feedback loops. So I'd just urge some caution when doing that. I will reference where I did this with a DLive console. And it does work, but you have to be very cognizant of how you're splitting out your message, your return messages, so that you don't end up with an infinite feedback loop and just really flooding your network with just a ton of data stream between the two things. So anyway, I hope this is helpful. I hope this is less rambling and more instructional. And we'll see you next time.